Lesson 10.3, Operations with Radical Expressions. Our essential question is, how do you add and subtract radicals? We have two properties that we're going to work with. The first one says adding radicals, and the second one says subtracting radicals. And then our third vocab word is like radicands. What I want to point out to you is that the radical part that you see right here is the same. So that when you're adding and subtracting radicals, as long as they have like radicands, so the same number under the square root symbol, you can add or subtract them. So if they have the same number under the square root symbol, you can add or subtract them by either adding or subtracting the numbers that are in front of the radical. The radical piece does not change. It's very similar to working with like terms, like 5x plus 3x equals 8x. You add the coefficient numbers in front of the variables, and you don't change the variable part at all. The same thing is true with radicals. As long as they are like radicals, like radicands, just like terms. Like terms, you add or subtract just the numbers in front. 7x minus 2x would be 5x. So now the radical part, or the radicand, we're treating it very much like we treat like terms with variables. Okay, my first example, hopefully you look at and notice that right away it has like radicands. So all of these square roots are the same. So what that means is I can take all of the numbers that are in front and simplify them. And I only have to write the square root of 2 once. So 5 plus 3 is 8. 8 minus 1 is 7. So it's 1 times the square root of 2, or just the square root of 2. My next one has a couple of different radicals. So it's like working with a couple of different variables. So I'm going to do a little bit of grouping here, and I'm going to group together the ones that are alike. This one is alike with this one. So 8 times the square root of 3 plus 1 times the square root of 3 would be 9 times the square root of 3. Notice I put a 1 in front of the radical, just like when we work with variables and you don't see the coefficient, it means there's one of them, so you can put a 1 in front. My next set, I have negative 2 times the square root of 5 plus 3 times the square root of 5. Negative 2 plus 3 is 1, so 1 times the square root of 5, or just the square root of 5. Simplest form. So the first one is 1 times the square root of 2, or just the square root of 2. The second one, 9 times the square root of 3, plus the square root of 5, or 1 times the square root of 5. Okay, this next problem, we are going to be using some of the skills that we worked on in section 10.2, because these radicals right now are not the same. I don't have like radicands here. So I'm going to do a little simplifying first. 54 is 9 times 6. And 24 is 4 times 6. So because what I did was I took out the biggest perfect square factor for each, so I'm just factoring those radicals. So now if I simplify, the square root of 9 is 3, and the square root of 4 is 2. So what's happening here is I get 12 times the square root of 6 plus 4 times the square root of 6. Remember, I'm just multiplying together these numbers that are kind of like coefficients. Now I can add together 12 plus 4 is 16. So my simplest radical form is 16 times the square root of 6. So I broke down each of those square roots by factoring out the greatest perfect square factor. And then what happened is they did turn into like radicals for me so that I could add them together to simplify. The next one, we'll do the same thing that we did on the last one. So we are going to factor 12 is the same as 4 times 3, so the square root of 4 times the square root of 3. And 48 is 16 times 3. 16 times 3. Remember, you're looking for perfect square factors. So 48, you may have thought was 24 times 2 or 6 times 8, but those aren't going to help us. We could have used 4 times 12, but that wouldn't be simplified enough. We would have had to break it down again. So now, my perfect squares, 4, the square root of 4 is 2, and 16, the square root is 4. So, 4 times 2 is 8, 8 times the square root of 3 minus 6 times 4 is 24 times the square root of 3. 8 minus 24 is negative 16, so negative 16 times the square root of 3 is simplest radical form. Oh, now we've got some work to do on this one. We've got 3 of them. 3 of them. Okay, the first one, 18. Let's go with 9 times 2. The square root of 9 is 3. So 6 times the square root of 2. The next one, switch colors here. The square root of 32 is 16 times 2. 16, the square root is 4. So this one would be 8 times the square root of 2. And then the last one, 72, we've seen before, is 36 times 2. So 6 times the square root of 2. So we are adding together because we have addition in between these. So we are adding these all together. So 6 plus 8 is 14, plus 6 is 20. So 20 times the square root of 2. So the whole purpose of simplifying them is to try to get them to be like radicals, like radicands. So sometimes they don't end up to be all alike, sometimes they do. Just make sure that you simplify them as much as possible. This next one, we'll have to see if they all turn out to be alike. Okay, so 24 is 4 times 6. So 2 times the square root of 6. 54 is 9 times 6. So 3. So 3 times the square root of 6. And I'm going to try to see about dividing this 96 by 6. 6 times 1 is 6. So 16. So 16 times 6, that works. So 4 times the square root of 6. All right. Now we've got subtraction and then addition. So we need to subtract and then add. So 2 minus 3, and then it will be plus 4. So 2 minus 3 is negative 1, plus 4 is 3. So my final answer is 3 times the square root of 6. Hopefully you're getting the hang of this. You should be able to write a summary now. And here are your homework problems.